Hello and welcome back. We've still got the AMC325, serial number 1493 on the workbench. Went ahead and replaced the P-channel MOSFET and the 20 volt Zener diode. You can see it's a copper color now, whereas before it was a bluish color like that one. And yeah, so I thought this would be more exciting, but the gate drivers are smart and they know that they're not actually hooked up to anything. And so I think it thinks it's saturated all the time, and it just puts out a little tiny blip. But I can show you that it at least is functioning, because they should be outputting a positive and negative signal, and they are. So I've got the good gate driver hooked up on the scope here. And we'll let it focus, maybe. Maybe. Look, something changed. You're not gonna focus? Come on. Look, text. There we go. Okay. So we're at 0 volts here. I can put on ground. We're on half a volt of division. And you can see we're at 0 volts. It's off a little bit here. You can get it right on the line. Anyways, close enough. I'm going to go ahead and turn the motor controller on. You can see that instantly she drops down to negative 9 volts. And if I put it in gear, so we're forward now, and I give it just a little bit of throttle, see this little tiny dot that appeared? Let me go turn the throttle down, see how it goes away. Comes back. You can see the trigger light comes on too. That is the how long it's staying on for. It's very quick. Let me go ahead and zoom into it here. Crank the intensity up to a bazillion. So we're talking. What does that look like? We're on 1 microsecond to half. Let's go to 1. It's always easier. So we're on 1 microsecond to division. We'll move this over there, and we're about 0.8 at 1 microsecond. So it's a very, very, very tiny pulse. But you can see that this was our 0. So we're at 5, 10, 15, about 17-ish volts right in the middle there, 17.5 volts. And then we're getting down to negative 9. So that's what a working gate driver looks like. So I'm going to go ahead and zoom back out here. Turn the intensity down before we burn out the scope. And you can see the couple dots there. And we're at 2 milliseconds of division. So we're not super fast now. So yeah, you could do 1, 2, 3, 4, 5. It's about 5.2 times 2 milliseconds. So we're not horribly fast. But you can see that's what it does. And what I'm going to do is pause it, and we'll flip over to the newly repaired gate driver. So I'll go ahead and flip this back off. Go like that. Turn that off. And I'm going to pause it because I don't want to accidentally short anything out. So hold on. Okay, we're back. So we're now on the middle gate driver. This is the one that's repaired. You can see it's got the other color, copperish black, copper and, well, orange and black Zener in there, and the replaced P-channel MOSFET, and we're on the same thing. We're measuring across the source and the gate, so we're looking at VGS that it's using to turn on the big MOSFETs, the ones that we replaced. So back on the scope again, you can see that we are sitting at ground. I go ahead and flip it on. You see we drop down negative 9 volts as well. Put it forward and give it a little throttle, and you can see the same little dot appears. And if we zoom into it and give it some intensity, you can see that it's going to the same voltage as the other one, as the good one, and same on time and everything. So pretty sure that that's fixed now and that it's working, and I think we're ready to go ahead. Oops, I should probably turn the intensity way down before I do that. There we go. Turn that down. And we're ready to go ahead and I think actually try plugging in the gate drivers and hooking up the motor and seeing if she spins. Yeah. So anyways, thanks for watching. Bye.